All right, let's take a look at this worksheet for section 2.4. Here we're dealing with the slope-intercept form of the equation of a line. And so when I write my line as y equal mx plus b, m is the slope of the line and b is the y-coordinate of the y-intercept. So on this table, we have a slot for the line equation, the line slope, and the y-intercept of the line. And you're given some of the information and need to fill in the rest. So remember, y equals mx plus b is the form of a line equation that gives m as the slope. That's a measure of how the line is changing. And b is the y-coordinate of the y-intercept. So here I see that the slope, which is always if y is isolated on one side of the equation, on the other side of the equation, the coefficient of x is my slope. So here my slope, m, is 2/5. The y-coordinate of my y-intercept is 3. That's my b. So my y-intercept is the point 0, 3. Now in the second line, I'm given the slope and the y-intercept, and I need to give the equation. So y equals the slope, which is 3 times x, plus the y-coordinate of the y-intercept, which is 2. On number 3, I'm given the equation, and I need to fill in the slope and the y-intercept. So notice y is isolated on one side of the equation. On the other side of the equation, negative 1/3 is multiplied by x. So that tells me my slope m is negative 1/3. I have subtracted from that 3. So that tells me the y-coordinate of my y-intercept is negative 3. So the y-intercept is the point 0, negative 3. So whenever I'm at a y-intercept, the x-coordinate is always 0. All right, now in number 4, I have a slope of 0 and a y-intercept of negative 5. So that tells me y is 0 times x plus a negative 5. That's y equals mx plus b. But 0 times x is simply 0. 0 times any number always gives me 0. And notice how this simplifies to y equal negative 5. So that's the equation of the line. Since the slope is 0, when we multiply 0 times x, we simply get a 0. So this is a case where all the points on the line have the same y-coordinate of negative 5. The x-coordinate changes, but the y-coordinate is always negative 5. So this is the form of a horizontal line. It's a line that has a slope of 0. When I look at this number 5, here I have an equation, 5x minus 6y equal 24, that is not in the form that allows me to determine what the slope is. So I need to solve this for y. So I'll subtract 5x from both sides of the equation. I can look at it as adding a negative 5x. So I have negative 6y equals negative 5x plus 24. And now I'm going to divide every term by negative 6 in order to isolate y. So the equation becomes y equals, so negative 5x over negative 6 is 6x. That double negative turns into a positive. Positive 24 divided by negative 6 is negative 4. So from that, I see that the slope, which is the coefficient of x, when y is isolated on the other side of the equation, is 5/6. So the slope is 5/6. The y-coordinate of the y-intercept, my b, is negative 4. So the y-intercept is the point 0, negative 4. So slope compares the change in y, which we often call the rise, to the change in x, which we call the run. So it's a comparison of how y is changing to how x is changing as I move along the line. So let's look at some of the other information. We have a picture of a graph, and we're being asked to write the equation of the line. Now what you'll notice here is that this is a horizontal line. So the slope is 0. Notice that the y-intercept here, here's our x-axis, is negative 3. So if we just kind of follow the process of what we've been talking about, y equals 0 times x plus a negative 3. 0 times x is simply 0. So y equals 0 minus 3 simplifies to y equals negative 3. So that's actually the equation of our line. Horizontal lines always merely have an equation that gives the y value. All points on the line have the same y value but different x values. All right, let's look at number 7. Here we have a line where we see that our y-intercept so here we see that our y-intercept is 2, 0, 2. So b is 2. Now to find the slope, we see that if I start at the y-intercept, I have to move 1 unit up. So since if I go 1 unit up, that means the rise is a positive 1. And notice I have to go 1, 2, 3 units to the right to get to this other point on the line. So up and right are positive directions. So both the rise is positive and the run is positive. So the slope is positive. And that's enough information for me to write the line equation. y equals 1/3 x plus 2. Now, when I look at the next problem, I see that my y-intercept is 7. So b equals 7. I see that from this 7, I move 1, 2, 3 units down. And then I have to move 1 unit to the right. So a down movement is negative. So my rise is negative and my run is positive. So the slope is negative 3. So y equals mx plus b, y equals negative 3x plus 7. Here I have on number 9, I have a y-intercept of negative 2. So b is negative 2. Now I notice that my slope, I have to move 1, 2, 3 units up, and 1, 2 units left to go from one point on the line to the other. And notice I'm picking movements that cause me to land at integer values for my x and y coordinate. So 3 units up means my rise is a positive 3. 2 units left means my run is a negative 2. So left is the negative horizontal movement, up is the positive vertical movement. So my slope is negative 3/2. So my line equation is y equals negative 3/2 x minus 2. Number 10, I have a y-intercept of negative 3. And I notice that if I move 2 units up from that point, so the slope tells me how to move from one point to another, so I move 2 units up, then I notice that I have to go 1, 2, 3 units to the right to get back on the line. So the slope, both of these are positive movements, so the slope is positive 2/3. So my line equation is y equals 2/3 x minus 3. Number 11, my y-intercept is actually 0. I'm right at the origin, the point where the x and y axis cross. So b is equal to 0. M, I see if I move 1 unit up, I have to move 1 unit right to get back on the line. So the slope has an upward movement combined with a rightward movement. So I have +1 for rise, +1 for run. So 1 divided by 1 is 1. So my slope is 1. My y-intercept is 0. So y equals 1 times x plus 0. Y equals to x. So that's the line equation there. Y equals to x. All right, let's fill in these blanks. A line with a blank slope slants up from left to right. So whenever my line is slanting upward from left to right, that actually indicates that the slope is positive. When my line slants down from left to right, as you probably guessed, my slope is negative. So a line with a negative slope slants down from left to right. A horizontal line has 0 slope. A vertical line has what we call undefined slope. And that's because there's no change for undefined slope. Your rise over run. When your line is vertical, there's no change in x, but there is a change in y. So you have whatever your rise is. If there's no change in x, then your run is 0. So you have some number divided by 0, which is undefined. Okay, and that brings us to the end of the worksheet. So this allows us to think about the slope-intercept form of a line equation.